evaluating alternatives. So we're going to look at a couple of different methods for comparing different alternative investments. So we have a 5-year life here for these three choices, and there's an alternative A, B, and C. And we have a initial cost of $2,000, $3,000, $3,500, savings annual of $600, and then salvage of $500. Okay. So what we're going to look at is the first one we'll do is payback, and then net present value, and then benefit cost. All right. So the payback is just really undiscounted the number of years that it would take, or number of periods that it would take to pay off your costs, your initial cost, with the savings. So this divided by this. So the lowest one's the best one. That's it. Net present value. Well, we have a cost of $2,000, and then the present value of the savings. So we have a rate. Whoops. Hold on. We have to have a rate and a life, of course. Discount rate is 10%, and life is 5. Notice it's the same life for all three. That's why we can use this net present value and benefit cost method. Okay, so net present value of alternative A is a cost of $2,000, and then present value of the savings. So we have a discount rate of 10%, number of periods of 5, and then a payment. And I'm going to put it in as a negative because of the weird nature of the payment PV function in Excel. If you put it in positive, it comes out as a negative value. And then, of course, the salvage value. Let's put that in, even though it's 0, because I'm gonna do something to save some effort here. So I'm gonna present value. The rate, I'll use 10%. Number of periods is 5. Now this isn't a payment, so I'll skip that one and go right to future value. And again, it's a positive, so I'm going to take the negative of it. And I think that'll do it. Whoops, wow. Oh, I know, that's because it's in percent. Hold on, there we go. All right. So I'm going to just copy this. That way I can just copy this formula. All right, so I have the net present value. The highest one is for B. And then the benefit cost is the present value of the benefits divided by the present value of the costs. So the benefits are rate, number of periods, and the payment is that. Right? And then the other benefit is the present value of the salvage, 10%, 5 years. But now it's a future value, and we're going to make it a negative And then I'm going to divide that by the cost. And so the highest benefit cost is here. Not surprising, these are kind of as this decreases, which is the best one, this increases, which is the best one. So these are kind of reciprocal functions. And then the last one, was I going to do another one? No, that's it. Okay. So that's it. But it also asks for us to sketch the net present value versus discount rate. So we can do that for all three alternatives. All I'm going to do is create the table. I want to show you the table function again and how it can be used. So I have discount rate under here and net present value under here. So this one, and just to differentiate, okay, this is for A. Okay, so the net present value for A is right here. I'm going to reference that one. And I want to do, I think it asked for 0%, 5%, 10%, 15%, and 20%. I don't know if that's what it asked for. I think that's what it did ask for. So we're going to use the table function to fill this in. So if I highlight this and then do what if data table. Now what values am I going to use to fill this column? Well, I'm going to use the interest values, right? So it's a column input, and it's the discount rate that varies to fill in that column. And there you are. And you'll notice the 10% number is the same. Right? So I could create a chart showing this. I can do the same thing with alternative B if I want to. Okay. And let's just do that real quickly. Again, I'll make this yellow just to make it pretty. And I'm going to reference net present value of B. And the discount rate has the same ranges. And I'm going to do the same what if data table. And again, it's what's the input to fill in this column? And it is the discount rate. And again, notice that the 10% is the same value. Okay, that's it.